Hello everyone. So today we are going to solve this question, first missing positive number. And to solve this, let's quickly go through the statement, what they are trying to say. Okay, let me bring this question problem over here. Yeah. Given an unsorted integer array nums, return the smallest missing positive integer. You must implement an algorithm that runs in O(n) time and uses constant space. Okay, we will worry about this thing later. First, let's try to understand the question. So what they are saying is, we will be given an array. Okay, let's say this is our array 0 1 2 0. Okay, so they are saying if we sort this array, if this array is sorted and all the numbers are in increasing order, then what is the first missing positive number? Like in this array 0, it's not positive, we ignore this. First positive number is 1, it is present in array. Second positive number is 2, it is present in array. Third positive integer will be 3. So the first missing number in this sequence, which is smallest positive number, is 3. First positive number which is missing in this sequence is 3, because that is not present and it's the first number that is missing in this sequence. Okay, so let's try to understand it with one more example, this one. So the array is 3 minus 3 4 minus 1 and 1. So what I told earlier, I mentioned it that if we sort this array, let's write in sorted order 1 3 4. So the first positive number is 1, that is present in array. Second positive number is 2 and it is not present in this array. So our first missing positive integer will be 2. Okay, that's the question. I think the question is clear. We can use one more example if we would still want to try this. Yeah, let's say the array is something like this: 5 4 2 3 8. Okay, so the first step is, let's write this in sorted order: 1 2 3 4 5 8. So first positive number is 1, it is present. Second positive number is 2, it is also present. Third positive number is 3, it is also present. Fourth positive is 4, it is also present. And fifth positive is 5, it is also present. Sixth positive number is 6 and that is not present in this array. It means 6 is our first missing positive number. Now I think the question is pretty much clear. Yeah, so let's try to think of solution, what we can do. First let us try to solve it using brute force algorithm. Okay, so the brute force is it's simple. The array is given, okay, and we need to find first missing positive. So let's try with the smallest positive number, that is 1. Is it present in this array? Yes, it is present. So let's try to find second positive number, because the first one is present. 2 is present in this array. Yes, it is present. Let's try to find third missing positive. 3 is present in this array. Yes, it is present. Let's try to find fourth missing positive. It is present. Yeah. Fifth positive integer. It is also present. Let's try it for 6. Yeah, it is not present. It means 6 is our first missing positive integer. So this is the brute force algorithm. We try with the minimal positive integer and we increment it with 1 and we check which one is not present in this array. It will work, it will definitely work, but first let us try to write a brute pseudocode for this. Okay, if we are going to implement this, let's try to write a pseudocode for that. So what we are doing is, we are traversing from smallest positive integer and incrementing it one by one and checking if the number is present. If it is present, we move to next number. Still present, move to next number. If it is not present, then that is our answer. Okay, so we can say we will use a loop from I equal to 1 till I is less than length. Why I am writing this length, it's I will explain it later, but let's assume we have a loop, and in this we are what we are doing is check if I is present in array. And for checking this, we know we can simply use a linear search, that is simply loop over this array and check if this index is equal to our given value, if this index is equal to our given value, and if this index is equal to our given value. So first let me explain why I used this length here. Okay, as I mentioned earlier, like if we write this array in sorted order, the array will be 1 2 3 5 and 8. Okay, so why I'm checking I, it will be less than equal to length. Okay, why I am checking it less than equal to, because let's say this array is of size n and it contains all the numbers till 1 to n. So the smallest positive number will be n plus 1. Okay, because an array of size n can contain from 1 to n numbers if all the numbers are present. Okay, and the first missing will be n plus 1. But if any number is missing in between, let's say it's number 3 is missing, so the 3 will always be less than this length, will always be less than this n, and this n is length in our example. So that's why I used length less than equal to length. Okay, so if we are going to solve this question using this algorithm, then let's check the time and space complexity for this. Okay, first let's analyze space complexity. I think we are going to use a single variable. Okay, a single variable, are we going to use it? We will check if this is present, this is present, this is present. Yeah, we are going to use a single variable, that is I, and space will be of 1. We are not going to use some another array, so it will not cost us space. But let's try to check the space complexity for every integer in this sequence. For every number in this sequence, what we are doing is we are checking this whole array. For every number in this sequence from 1 to n, we are checking this whole array if the number I that ranges from 1 to n is present in this array or not. So for a number time complexity, so for a number we are going to traverse this array of size n. And how many numbers are there? There can be at most n numbers, so n into n, which is of n square. Okay, so that will be our time complexity if we use this approach. But obviously we are not going to use this, because we are expected to solve this in O(n) time and extra space, O(1) extra space, constant extra space. Okay, so let's discard this algorithm because it takes a lot of time. I think there is some lag in this software. Okay, so let's try to optimize this. What we can do is we can simply use whatever we use to understand the question, is that sort this array. Okay, whatever the second best approach I am thinking right now is that we can sort this array. If we sort this array, the array will be 1 2 3 4 5 8, and then I will use a variable I equal to 1, and I will check if I is present as this index. So I plus 1 yani ki 2 will be at this index. I plus now I is 2, 3 will be present at this, 4 will be here, 5 will be here, and now 6, yeah, it is missing. So our first missing positive number will be here. We can simply do a we can simply traverse linearly. Okay, let's take a number, let's say missing positive equal to 1. If 1 is present as index 0, move forward. If and while moving forward, we increment this number. If 2 is present here, move forward and increment this number. Find 3 here, move forward. You can simply traverse it. Okay, so this can work, but again, let's try to check time and space complexity. Okay, let's analyze time complexity first. Okay, so for solving this, we need to sort this array, and the best sorting algorithm is, I think, of n log n. Okay, it takes of n log n time, and after sorting we are just simply linearly traversing the array, so it takes of n time. So while comparison time, we take the one which is larger, so that is of n log n. It is much better than n square, but still not our optimal solution, because what we need is, we need this in on time. So what else we can do to solve this in on time? Okay, what we can do, I think, yeah, the solution comes from this sorted array. Here we are sorting this array, and then we are finding these numbers. I can use some information which is provided in the question that is not directly available, but we can think of that. And that algorithm is, that information is, if all the numbers are present in this array, it means if all the numbers are present in this array from 1 to n, the worst case is all the numbers from 1 to n are present in this array, so our first missing positive will be n plus 1. If all of these are present, it means we can simply sort this array in on time. Why I'm saying on time, I will explain it later. But if all the numbers are present, then the first missing positive will be n plus 1. And if they are not present, let's say if some number x is missing in this, so what can take place of this x is a number less than 1. Okay, let me rephrase it again. If, let's say, from this sequence 1 to n, a number x is missing, so what number can take place of this x? The number can be any number less than 1 or any number larger than n. Okay, any number larger than n, or we can simply say x will be less than 1 or n will be less than x. Any number larger than n or any number less than 1 can take place of this x. Okay, so using this information, we can sort this array in on time. How I'm going to do that is, let's check it. No, let's not erase it. Okay, so assume this array is sorted like this. And these are index 0, 1, 2, 3, 4, 5. If this array, if we want this array to be sorted like this, then we can say that this 1 will go to index 0, this 2 will go to index 1, this 3 will go to index 2, this 4 will go to index 3, this 5 will go to index 4. Okay, this is a bit of mess. Let me write it here: 0, 1, 2, 3, 4, 5. If the array is sorted, index 0 will contain 1, index 1 will contain 2, index 2 will contain 3, index 3 will contain 4, index 4 will contain 5. I think this pattern is clearly visible, because if all the numbers between the range 1 and n are present in this array, then index of all these numbers will be 0 to n minus 1 if all of them are present. And if some number is missing, then let's say a number x is missing, it means the index x minus 1 will contain some other number. Okay, like in this situation, number 6 is missing, so 6 is missing, and 6 minus 1, that is 5. Index 5 contains some other number. Okay, so this information will help us to find the first missing positive number. Okay, let's try to sort it. You will get it while I am solving this. It's very easy. 0, 1, 2, 3, 4, 5. Okay, I will traverse from this index, and what I will do is I will place this number at its appropriate index where it belongs. What I will do is I will pick an index like index 0, and I will simply place this number 5 at its exact appropriate position where it belongs. It means index 4, at index 4, because we just saw that 0 to n 1 to n numbers between 1 to n will be on indexes 0 to n minus 1, and they are directly related. Okay, number 1 will be at index 0, number 2 will be at index 1, number 3 will be at index 2. So let's try to solve it. Index number 5, this number is 5, it belongs to index 4, so let's just swap these numbers. Okay, 5 and 3, let's swap it. 3 is here, 5 is here. So in this operation, what we did, we placed number 5 at its position where it belongs, where it needs to be if this array is sorted. We placed one number at its exact position. Okay, now the number is 3. We are not going to move forward until this number here is 1, or any number which is less than 1, or any number which is greater than n. Any number x which is greater than n. We are not going to stop until then. You will get it. Let's move forward. So in number 3 belongs to index 2. Number 3 belongs to index 2. So let's swap these numbers. It's 1, it's 3. So in this operation, what we did, we placed the number 3 at its exact position where it belongs, and it may happen this index also gets sorted. It's not necessary it will always be sorted, but may happen this index gets sorted, like in this case right now. Okay, and now we check that index 0 contains number 1. Index 0 contains number 1. It means it's the time to move forward because the array is sorted. The array before this is sorted. Okay, so let's move to next index here at index 1. Now index 1 can the appropriate number for this index is index 1 plus 1, which is 2. So we need 2 here, or what we can say is this 4 do not belong to this index, it belongs to index 3. So just swap it. 2 and 4. Okay, we swapped it. Now this index is sorted. It means if this is at its exact position and we had sorted the indexes before that, we can move forward. Now index 2 contains number 3. It is also sorted. Move forward. Index 3 contains number 4, it is also sorted. Index 4 contains number 5, it is also sorted. Move forward. Index 5 contains number 8. Number 8, okay, but let me rewrite it. We need numbers from 1 to n. 1 to n. So if any number which is less than 1, any number x which is less than 1, or any number x which is greater than n, if we encounter any of these numbers, we leave them as it is. We do not swap them, we do nothing, we just move forward. And now we are at the end of array. Now what we can do is we can simply traverse from 1 2 3 4 5. Oh, 6 is missing. That's our answer. Let's say if this index is 6, we will go from 1 to n, all the numbers are present. From 1 to 6 all are present. The first missing positive will be 7. Okay, I think the algorithm is little bit clear. Okay, so let's try it with this example, 3 4 minus 1 and 1, to understand it more clearly. 3 4 minus 1 and 1. So let's write the indexes 0 1 2 3. Okay, we are at index 0 and it contains 3, but this position is not valid for 3. So let's take 3 to its appropriate position. So 3 belongs to index 2. Move it there. Minus 1. Oh, let me use this pen. Minus 1 and 3. Again, in single operation, we fixed this index. Now, index 0 contains minus 1, and as I just told you that if any number x is less than 1 or any number x greater than n, we do not touch them, we leave them as it is. Okay, so this number minus 1 is less than 1, we are not going to touch it, we leave it as it is. Okay, we move forward. We are at index 1. So index 1 contains number 4, and number 4 do not belong to this index. So what we do is we swap index 1 and 3. Okay, so 1 comes here and 4 goes here. Now after this operation, this index, is it sorted? Number 1 belongs to index 0. So what we are going to do, we swap it again, because this is not the right position for this 1. It belongs to index 0, because in sorted array it will be something like this. 0 1 3 1 3 4 minus 1. Let's assume these are not in comparison, so the sorted array will be 1 3 4. Okay, and if the sorted array is something like this, 1 3 4, we can say number 2 is not here, so it is missing. Okay, so this one belongs to index 0, just swap it. If it do not belong here, why we keep it here? Let's swap it. Okay, now again this condition, this number x is less than 1, so we leave it as it is, we do not touch it. Move to this place. Now index 2 contains number 3, it is exactly where it belongs. Move forward. Index 3 contains number 4, it is also where it belongs. Move forward. We are out of our array, so the first missing positive will be index 0 contains number 1, it's correct. Index 1 shall contain number 2, but it is not there. It means our first missing positive number is 2. Okay, so one last example, and by this it will be clear very well. 5 4 minus 1 minus 2 1 2. Let's say this is our array. This is a example which is quite a bit larger, so it will be easy for us, it will be beneficial for us to understand this algorithm properly. Then we can figure out the code and we can move to the coding screen. So index 0 have 5 and this 5 do not belong to this index, so let's move this 5 to its index where the index where it belongs. Okay, so 5 and 1 are swapped, 1 is here, 5 is here. Okay, now this one is at its exact position where it belongs. We come to next index. Index 1 contains number value 4, it do not belong here, so let's swap -2 and 4. By this operation we confirmed that 4 is at its exact position. So, and this index 1 contains a value less than 1. This -2 is less than 1, so in this case we are not going to touch it, we'll leave it as it is. We are at this index. Here also index 2 contains value -1, -1 is less than 1, we are not going to touch it. Okay, because all we have to worry about is the numbers from 1 to n. We have to only fix these numbers. We have to make sure that all the numbers in range 1 to n are at their appropriate indexes 0 to n-1 respectively. 1 at index 0, n at index n-1, and any number x at index x-1. We have to make sure that these are at their appropriate position. Okay, any number less than 1 and any number larger than n, we can leave them as it is. We do not need to fix them, and we cannot according to our requirement, our question. Okay, index 3 contains number 4, sorted. Index 4 contains number 5, sorted. Let's move forward. Oh, I think there is some issue. No. What shall I choose? Wait. I know this is not going to work. Force quit. Let's open it again. This is crashing a little bit. Let me try to open the last page. So we were at this index. Okay, index 5 contains number 2, but this do not belong here, so let's try to move this number to its exact position at index 1. So we swap this 2 and -2. 2 comes here and -2 comes here. So now this number is less than -1, so we move forward and we reached at the end of array. Now first number is 1, present in array. Second number is 2, present in array. Third number is 3, not present in array. It means this one is missing. We just have to compare. Index I, that is 0, contains number I plus 1. Or this is not we do not have to use the equal sign. We can say that nums of I, if not equals to I plus 1, it means I plus 1 is missing. Okay, so what I'm trying to say is we can write this equation something like this. If nums of I not equals to I plus 1, it means I plus 1 is missing. Like let's start with the index I value 0, I equal to 0. So at index 0 it is 1, so the condition is not true. nums of I, let's say I is equal to 0, so nums of 0 is 1, and we are checking if it is not equal to I plus 1. I 0 0 plus 1 is 1, but it is equal to, so we are not going to enter in this. If we move forward, I is 1, do nums of I, that is 2, nums of I is 2, not equal to I plus 1, 1 plus 1 2, no, they are equal, so we move forward, we come I value becomes 2. Now nums of I, that is minus 1, if it is not equal to I plus 1, yeah, nums of I is minus 1, and it is obviously not equal to I is 2, 2 plus 1 is 3, so minus 1 not equals to 3, yes it is true, it means I plus 1, that is 3, is missing number. Okay, 3 is missing. So this is our code, this is our solution after we sorted this array. Now let's try to write a pseudocode for sorting the array. Let's try to write the pseudocode for sorting the array. What we are going to do is we are traversing this array from 0 to n minus 1. Okay, we are traversing from index 0 to, yeah, it's okay, we are traversing from index 0 to n minus 1 in last index. Okay, we are traversing through this array, and now what we are going to do is if first we are going to check if this number is in our range, so that we need if we need to fix it. What I was saying at that time, if nums of I, nums is this array, and this is my handwriting, nums of I, if it is greater than 0, we need to check the numbers from 1 to n, in range 1 to n. If it is greater than 0 and nums of I is less than equal to length, if this is the case, first what we are going to check is if this number is in range 1 to n, then only we are going to check if we need to swap this or not. Okay, first we need to make sure that this condition is true. After, if this condition is true, then we are going to worry about that we have to swap this array or whatever. Okay, and yeah, so now if this condition is true, then let's try to find the index where this number belongs. Any number at index I, belongs to some other index. If we are going to find that index, we can say that potential index for number at nums of I. What I am trying to find is where this number 4 belongs. It belongs to index 3. So how we are saying that potential index is equals to nums of I minus 1. So let's say nums of I is equals to 8. So for 8, the potential index will be nums of I 8 minus 1 7. It means we need to transfer this 8 at index 7, like we did here. We transferred this 5 from here. Okay, 5 was here, index I is 0. If we say nums, let's say I key value 0, let's say I is equal to 0, what we are going to do is nums of I, that is 5 minus 1 is 4. So it means for this number 5, the potential index where it belongs is index 4, nums of I minus 1. Okay, so first what we are going to do is we are going to find the potential index, and then we are going to swap it. So now I am going to check if nums of potential index, it means the number placed at this index, if it is not equal to nums of I. Okay, if it is not equal to this index, then swap. Okay, then we are going to swap it. Why I am saying this? It's a reason. Let's say if the array is sorted, so what we are going to do is we are going to find potential index for 1, and potential index for 1 will be 0. So what we are checking is, if nums of potential index is 0, nums of potential index is 1, if it is not equal to nums of I, it means this condition checks that we are not talking about the same number. Or we can definitely do it much easier if we simply say potential index and I are not same. We can say that if potential index and I are not same, then only swap it. Okay, if all them, it means that this number, if this number is not at its exact position where it belongs, then only swap it. That's it, and that's our code. Okay, that's our code. So let's move to the coding screen. Ubuntu ran into some problem. I don't want to send it. Okay, yeah. So what we are going to do is, first we are going to find length of this array, and that is nums.length. Now we are going to sort this array. Okay, what we are doing here is we are sorting the array. For int index equals to 0, idx is less than length, idx plus plus. Okay, and in this, the first step was checking if the number is in range. Okay, the first step was checking if the number is in range. If you remember, this was our first step, to check if the number is in range. So we are going to say if nums of I is greater than 0 and then nums of I is less than equal to n, 1 to n, okay, is less than equal to length, because we are using the word length instead of n here. So we can say it's less than equal to length. If this is the case, then find potential index for this nums of I, and it is nums of I minus 1. And if we find this potential index, then what we are going to do, then we are going to check if this number is not at the exact position where it belongs. If it is not, this potential index is not equal to I, this index itself, it means it is not at the position where it belongs, then swap it. So for swapping, let's say we take a temporary number, that is nums of I, and nums of I equal to nums of potential index, and nums of index equals to temp. So we just swapped it. And yeah, one more thing, and it is majorly important, this I minus minus. So I think you can definitely figure it out why I'm doing I minus minus. Try to think about it, or otherwise I will explain it at the end of the question. So when we are done with this, then we are going to find the first missing positive number. So let's say for int number equals to 0 and till number is less than length number plus plus. And I think I do not use this variable namer. Let's say if index, yeah, this will be much better, index. So after the array is sorted, at every index I, the number, if it is sorted, the number will be I plus 1. For each index I, the number will be I plus 1. If it is not the case, it means I plus 1 is missing. So if nums of index not equals to idx plus 1, if it is not equal to, then return idx plus 1, otherwise it's okay. And if all the numbers are present, we will reach at this point only when all the numbers are present. In range 1 to n, if in range 1 to n, or we can say length, because if this condition holds true at any point, we are not going to reach at this point, and if we are reaching at this point, it means all this condition was never true. It means index I always contains index I plus 1, so the last missing positive will be length plus 1. So we have to return length plus 1. For this length plus 1 is for any array that is something like this, 1 2 3 4, index 0 1 2 3. So the first missing positive will be 5, that is length plus 1. Okay, and now let's try to think of this, why we wrote this I minus minus. It is very important because let's say if we are at this index and 4 is here, 2 is here, and I am at this index. Now this 4 belongs to index 3. I am going to swap it. Oh, just a minute. Let's say this 4, this is our array, 2 and minus 1. Let's say this is our array. Now this 4 belongs to index 3. So at this point of time, what I will do is I will swap this minus we are going to swap 4 and minus 1. Yeah, minus 1 and 4. In this operation, we shifted 4 to its exact position, and we are still at this index. We are not moving forward right now. We will move forward once again by checking this condition. Okay, and this is also not making a sense. Let's say our first let's say our array is something like this, 5 minus 1 2, yeah. Let's say, yeah, it will be much clearer in this example. Let's say we are at index 1, so number here is 4. We are going to shift this 4 to its exact position, so we are going to swap 4 and 5. Okay, now 5 is here, 4 is here. Now still after swapping, we are at the same index. We are not moving forward. After swapping, we are not moving forward, so that's why what I did is I minus 1 minus. Okay, when this loop restarts at this point, it do I plus plus. Let's say at this point, oh, it's not I, it's idx. Let's say at this point index value is 5, so what will happen is 5 minus minus will be 3, and then 5 minus minus will be 4, and when it reaches at this point index plus plus, it will again be 5. it means we are not incrementing it. Okay, in this condition we are not incrementing it. Or we can use it by for loop, while loop, that is much easier. Okay, that's it. Let's try to run. What it is saying, oh, I have used I index, it's index. In the example we are repeatedly saying I, so that's why I wrote I here. Now one more position is left, idx. I think it's good, but this will cause problem. Yeah, it's accepted. Let's try to submit it. TLE. Oh, wow. TLE. It means we are missing something. We are missing something. Index 0 till index is less than length, index plus plus. If index is greater than 0, if nums of index is less than equal to length, potential index is index minus 1. If potential index not equal to index, if it is not equal to index, then what we are doing is we are swapping. Okay, we are swapping. Fine, index minus minus, great. Why it is giving TLE? Index 0 less than length, index plus plus is given 0. Care about this. Potential index. Okay, let's try to test for some other case. 4, 5, 6, 7, 8. So what will be the answer? It's 3, and that's fine. Working. Let's say if we have 3 also, and this array is sorted. It is giving output 9. That is also fine. And let's say if we have minus 4 here, it is giving 4. Then why it is giving TLE? This if condition is fine, we do not have to worry about this. Less than length or less than equal to length, this is also fine. Yep, this is complicated. What are we missing here? Num's total length will be in this range, 10 raised to the power 5, and the numbers can be in range there. That is also fine. Nums of index, let's say 1 is not equals to 0 plus 1, then return this. Yeah, I don't think anything is missing. Acha, they are giving this output also, for which it is failing. Sorry, not output, input. 1 comma 1. Oh, I got it. We have to not check this, we have to check the numbers, because the numbers are repeated. I got it. We do not have to check the indexes. Actually, we have to check the numbers, because the numbers are repeating. Got it. That's it. Yeah, it's submitted. So what was the issue in this line? What we are earlier what we were doing is we were checking if these indexes are different, but maybe there can be a case these indexes are not different, and these indexes are different but the numbers are same, and we keep on rotating there. Let me try to explain it with the example 1 and 1, 1 1. So what's happening in this case is this index 0, this index 1. We are here, we said that this one belongs to its exit position, this one belongs to its exit position. So what we do is, according to our algorithm, we move forward, and at this point we say this one belongs to index 0, so swap them. According to our algorithm, what we are doing, we are just swapping them, but both the numbers are same, and we are not moving our index I forward. Then again we are checking if I this, what we are checking is, we are checking potential index, that will be nums of I minus 1. Nums of I is 1, 1 minus 1 is 0, and in potential index is 0. Okay, and we are checking if potential index, that is 0, not equal to I, that is 1. I means index, that is 1. If 0 is not equal to 1, yeah, it is not, then we'll swap them. And what's happening, we are swapping this 1 again and again. We are just swapping it infinitely. Okay, we are swapping it infinitely. So that's why we do not have to check the position, we have to check the numbers, because there can be repeated numbers. Okay, the numbers can be repeated, so we have to check the numbers. Now if I check this, potential index is 0, and I is 1, so what I'm going to check nums of potential index 0, that is 1. If it is different, then nums of I, that is 1. If it is different, then only swap them. If they are same, do not swap them, leave them, move forward. That's why it was giving in TLE due to this indexes, but if we use number, then it will not give TLE. Yeah, okay, that's it. Let's meet in next video.